So we're going to continue section 5.5, which is about integration by substitution. So let's look at our first example. Find the indefinite integral. The integral of x squared plus 1 squared dx. Now remember where we left off, we were talking about doing U-substitution. And we were talking about which choice we should make for our U. So here, if you look, you're going to look for the composition, which is the second piece right here, and you're going to look at the inside, and that's going to be your U. So I'm going to choose U to be x squared plus 1. And then you're going to take the derivative of this equation. Du is 2x dx. But if you look at what you have in your integral, what do I have? I have x dx. So I'm going to divide this equation by 2, and I'll get 1/2 du equals x dx. So now we're going to do our substitution here. Start off with so the first thing, I'm going to substitute in place of x squared plus 1. I'm going to put in u, so this will be u squared. And then what do I have left? I have an x and a dx, which gets replaced by a 1/2. So I'll put the 1/2 in front, 1/2 du. So you can pull that 1/2 out in front, and then I'm integrating u squared du. Now notice when you do your u substitution, you should only have u's in your integral, no x's anymore. And now do your reverse power rule, u cubed over 3 plus c. And your final step is you have to put it back in terms of x. So you're going to plug in u was x squared plus 1. And there is my answer. Now if you have time when you're working on a problem, you can check your answer. If I take the derivative, look at your answer up here and take the derivative. So if I take the derivative of that, I'm going to do the chain rule, bring the 3 down, reduce the power by 1, and then multiply by 2x. So this 3 and this 2 cancel with this x. So in the end, I get x squared plus 1 squared. And if you check, that was the same thing we had when we started this problem, was x squared plus 1 squared. So in the end, I know that my answer is correct. So don't forget, you can check your answer by taking derivatives. Let's look at another problem. Let's find the integral of the square root of 2x minus 1 dx. So again, you're going to look for a composition, which I have here, and the inside of that composition is 2x minus 1. So that's going to be my u. Take the derivative of that equation, du. It's going to be 2 dx. And I'm going to, again, if you look in your integral, you only have a dx there, so I'm going to divide by 2. All right, and we're ready to do our substitution now. So this is, we started off with the integral 2x minus 1 dx. And now it's going to become, so this will become u. So the square root of u. And then in place of dx, we're going to put in a 1/2 du. So I'm going to pull the 1/2 out. And I'm going to write this with an exponent. This is u to the 1/2. And now we're going to do our reverse power rule, where we add 1 to the power. So it'll be u to the 3/2 plus c. So then if I simplify the denominator, I'll get 1/3 u to the 3/2 plus c. 1/3 2x minus 1 to the 3/2 plus c. And again, there's my answer here. And if you have time, you can check your answer by taking the derivative. So take the derivative of this. So you get 1/3, do the chain rule, 3/2, 2x minus 1, reduce the power by 1, 1/2, times the derivative of the inside. The derivative of the inside is 2. So these 3's cancel, these 2's cancel, and if you look back at the integral, this is exactly what we had to begin with in the integral, the square root of 2x minus 1. So our answer is correct.